shall we start, sir? Yes, sir, you are not audible.
Yeah, please give me a minute. I'm connecting my writing part to the PC.
Okay, okay, okay.
Okay. So working now. Let me try sharing my screen. Is my screen visible?
Uh, s- uh, Good evening, everyone. On behalf of the Mathematics Department, I am delighted to welcome Dr. Anand Chitrao, sir. Sir is a postdoctoral fellow at Harish-Chandra Research Institute, Prayagraj. His area of expertise lies in number theory, rigid analytic geometry, and Galois representation. So please welcome all of you to joining me in welcoming sir. Over to you, sir.
Thank you, Madhavi madam. So let's start where we left off last time. Is my screen visible?
Yes, sir.
Okay, so you must be able to see the problem sheet and a blank notepad, right?
Yes.
Okay. So before starting with the problem sheets, tell me if you have any questions from the last lecture. Are there any questions from the theoretical part as well as the problem solving part from the last lecture? Maybe we can begin with that.
सर
Yeah.
सर जो ग्रुप आइसोमॉर्फिज्म वाला क्वेश्चन था क्यों प्लस क्यों स्टार और क्यों पॉजिटिव
Uh-huh.
तो उसको एक बार दोबारा से बता दीजिए वो उसमें हाँ ये वाला
Okay. So, एक मिनट शुरू करते हैं. So, इसमें फर्स्ट पहले दो आइसोमॉर्फिक नहीं है, ये समझ गए क्या?
यस सर ये तो समझ में आ गया बट जो ये है ना क्यू पॉजिटिव कि ये क्यों नहीं होगा तो उसका नहीं समझ आ रहा.
राइट. क्यू पॉजिटिव वर्सेस क्यू प्लस.
यस सर.
ओके. सो मैंने कहा था कि क्यू प्लस की प्रॉपर्टी है कि इट्स डिविजिबल, राइट? व्हाट डज दैट मीन? इट मीन्स दैट अभी कोई भी रैशनल नंबर ले लिया, लेट्स से 5, ओके, एंड कोई भी नेचुरल नंबर ले लिया, लेट्स से 2, then there exists an element x in the group G, the group Q, such that 2 times x equals 5, right? What does this mean? This, by definition, is do the operation 2 times. So x plus x equals 5, right? So is there such an x which satisfies this equation? Is there such an x which satisfies this equation that x plus x equals 5 in rationals?
यस सर 5/2.
Okay, 5 by 2. So with this trick, you can see that 5 can be replaced by any rational number which you want, right? 5 can be replaced by 6, 7, 1.5, whatever.
Yes, sir. Yes,
You
sir.
can always divide by 2. So the group is divisible. But if Q plus and Q positive, these were isomorphic, then the same holds for Q positive, right?
Yes, sir.
So if Q plus is isomorphic to Q positive, comma dot, then this same property would hold for Q positive, which means suppose this isomorphism is given by, let's say, F. Okay. Now, um, we are assuming something and we'll prove we'll get some contradiction so that this is not true. Now, F is an isomorphism, right? So start with, let's say, 7 in Q positive. Okay. Now, F inverse 7, you start with F inverse 7. This is an element in Q, right?
Yes, sir.
Now, F inverse 7 divided by 2 is a rational number, which when added with itself gives you F inverse 7, right? This by 2 plus F inverse 7 by 2 equals F inverse 7. Not itself, I should say gives back F inverse 7. Now apply F to this equation. So you get F of F inverse 7 divided by 2 plus F inverse 7 divided by 2 equals 7, right?
Yes, sir.
Is this much fine?
Yes.
Okay. Now F is a homomorphism, so plus becomes dot. This means that F of F inverse 7 divided by 2 times F of F inverse 7 divided by 2 equals 7. What does this mean? This number F of F inverse 7, which is a positive rational number, right? Because you are applying F to something, the image of F is in Q positive. So this is a positive rational number whose square is 7. Is that possible?
No, sir.
No, sir.
Yeah, this is not possible. Therefore, we get a contradiction. Which means we must have assumed something wrong. And that wrong assumption is that there exists an isomorphism between these two groups. Is that fine?
Yes, sir. Thank you, sir.
Okay. Any other questions? Any questions from the theoretical part?
No, sir.
Okay. And what about the problems?
कर रहे हैं, थोड़ी बहुत हो रही है, बाकी इतना ज्यादा नहीं है प्रॉब्लम्स में दिक्कत।
Okay, okay.
हो रही है मतलब।
अच्छा है ये. So, should we begin with problem number 22? आगे बढ़े?
Yes, sir.
Yes, sir.
Okay, great. Chalo, can somebody tell me how to solve problem number 22? If every element of a group G is of order 2, then G is abelian. True or false?
True.
Yes. Reason क्या है? What's the reason?
Because
Your voice is getting broken. Voice is breaking.
so because every element are of self inverse.
Yes. So, what is the idea behind it? Okay, so it's a small trick. Does everybody know the sock shoes property?
Yes, sir.
What is it?
XY whole inverse equals to Y inverse X inverse.
Okay, this is Y inverse, X inverse. Right now, somebody said that if every element of a group is of order 2, then every element is an inverse of itself, right?
Yes, sir.
Yes, sir.
Which means xy inverse is xy and y inverse x inverse is
YX. Same
YX.
much.
y, which means
They
the group
commute.
is
It is.
away. Yeah. Now tell me, is there a group with exactly 2 elements of order 2?
No,
Why?
because
Because
in every group, because uh, order two element.
sir, it is necessary to exist a identity element, and identity element has order one always. That's why I guess.
But this says, is there a group with exactly 2 elements of order 2? So identity is not one of these.
नो सर, बिकॉज ऑर्डर टू एलिमेंट के इनवर्स का ऑर्डर भी टू ही होगा, तो एंड वो सेल्फ इनवर्स होंगे,
Right.
तो एक ही एलिमेंट हुआ ना, तो ऑर्डर टू का एलिमेंट कभी भी इवन ऑर्डर में नहीं मिलेंगे किसी भी ग्रुप में।
ऑर्डर 2 के एलिमेंट्स इवन ऑर्डर में नहीं रहेंगे।
मींस इवन नहीं होंगे, इवन इवन नंबर में नहीं होंगे वो।
क्यों? I didn't get the point. So you want to pair up elements, na? X and X inverse you want to pair, but X is
बट
equal to X inverse, so there is no pairing, right?
यस सर, यस सर।
What do you do? Let me give you a model. Suppose you start with X. So construct an element out of these two whose order is 2 again.
सर वॉइस नहीं आ रही आपकी।
अभी आ रही है?
हाँ सर।
Okay. So, suppose x and y are these two elements in G whose order is 2. There are two of them. Can you construct a third element whose order is 2?
देयर प्रोडक्ट।
No. Last time we saw, right, that you cannot say anything about the order of the product. In problem 17,
यस सर।
we saw that we cannot say anything about the order of the product, even if the order is small or whatever. Yeah, so the idea behind this problem is conjugates have the same order. Okay, so the order of x and the order of y x y inverse, these are equal. Is that okay?
सर सुना ही नहीं दिया आपने क्या बोला, आपकी वॉइस बहुत ही लो आ रही है।
अच्छा, अभी देखो. So what is the order of y x y inverse?
इट्स इक्वल टू ऑर्डर ऑफ एक्स।
Yes. So y x y inverse is an element of order 2 in the group, right? Because order of x is 2. But we know that in the group G, there are only two elements of order. Is that fine?
Sir, you are not audible.
Now am I audible? Let me
Yeah,
check my
it's
mic
fine.
settings. Yeah, now it must be better.
Yes, sir.
So y x y inverse is an element of order 2 again, right? Because conjugates have the same order.
यस सर।
But we know that in the group G, there are only two elements of order 2. Those are x and y. So y x y inverse must be one of them.
यस सर।
So case 1 is y x y inverse equals y. Is this possible?
No, sir.
Why?
Because it implies xy inverse equal to e. That is
Yes.
inverse of x is equal to y.
Because x is not equal to y.
So this implies you can cancel y to get x y inverse equals identity, which implies x equals y. But we started with two distinct elements. Okay?
यस
So
सर।
this is not possible. So case 2 is y x y inverse equals x. This means after multiplying by y on the right, yx equals xy. Okay? Is this fine?
Yes.
Now, can you tell me what is the order of xy?
LCM of R of x and R of x.
Yeah. So what's the LCM?
2.
Yes, for order of xy is 2, which means xy has to be x or y, right? Because these are the only two elements of order 2. Is this a contradiction?
Yeah.
Why? What's the contradiction over here?
Either X or Y is identity.
Right, either x or y is identity. So if xy is x, then you can cancel x to see that y is identity. If xy is y, then you can cancel y to see that x is identity, which is a contradiction. Which means that there is no group of order, there is no group in which there are exactly two elements of order 2. Okay? Any doubts to this point?
No, sir.
Okay, great. So let's go to the next question. We know that if G mod Zg is cyclic, then
G is
what's
abelian.
the common statement? Yeah. If mod Zg is cyclic, then so this is the usual statement which everybody says. So what is Z? Does anybody know?
सर सुना ही नहीं दे रहा आप.
Yeah, what is Z? What is Zg? Zg क्या है?
Center of group.
Yes, Zg is the center of
It's
the
a
group.
set containing elements which commutes with all the elements of the group.
Perfect. So Zg is a center which is set of all elements in G which commute with every other element in G. Okay? So this is the definition of the center. Now it's a standard fact which you should remember that if G mod Zg is cyclic, then G is abelian. The proof is also, yeah, you can prove this, but let's skip the proof. So one might try to generalize this, right? One might try to ask if G mod Zg is abelian, then is it forced that G is abelian? So what's the answer? It's already there on the screen.
No, sir.
Yeah. What's the reason? So D8 is that non-abelian group. Everybody knows D8 is non-abelian.
सर अगर G abelian हो जाएगा then ZG खुद G के बराबर ही हो जाएगा. तो इससे G by ZG का ऑर्डर 1 हो जाएगा और वो साइक्लिक हो जाएगा.
हाँ, वो रिवर्स है ना कि अगर G abelian हुआ तो क्या होगा? वो रिवर्स डायरेक्शन है ना? If
हाँ
if G is abelian, then Zg is full of G, and G mod Zg is cyclic because it's trivial. What about the other direction? If G mod Zg is cyclic, then is G abelian, right? Direction कौन सा है?
P implies Q.
Yes. So, is this okay? G mod Zg. So let's look at this. G mod Zg is abelian. Then is it forced that G is abelian? And the point is, you can take D8. Okay.
Yes, sir.
Just a minute. Yeah. So, is the reason clear? What is T8? T8 is the dihedral group of order 8. Does everybody know what T8 is?
Yes, sir.
Okay, it's the dihedral group of order 8. What's the
8,
center of T8?
sir, 8 नहीं 16.
Okay, that's a conflict of notation. Sometimes you write D2N, DN, but yeah, I wanted to say the dihedral group of order 8.
Yes, sir. Yes, sir.
Okay, so what's the center of the dihedral group of order 8?
Uh,
Identity.
What do you write?
Identity and R180.
Exactly. Identity and R180. So, what's the cardinality of G mod ZG?
4.
4. Now, every group of order 4 is abelian, right?
Yes, sir.
Because it's a square of a 4 is a square of a prime. So G mod ZG has cardinality 4, therefore G mod ZG is abelian, but G is not abelian. Okay?
Yes, sir.
Yeah. Is this clear for everybody? Okay. Let G be a cyclic group of order 2025. Then the number of non-isomorphic subgroups of G is, try this out on your own and maybe tell me later. Okay? There's a direct formula. Oh, just a minute. There's some
Sir,
voice
sorry to
issues.
interrupt you again, but your voice is cracking.
Yeah. Is it better?
Yes, sir.
Okay, great. Okay, let's skip 25 for the time being. Let's do some easy question now. What is the order of 2, 3, 1, 2 in GL2 Z mod 5, Z5? What's the order?
It's 3.
It's 3. So let's do that computation over here. 2, 3, 1, 2. So this is A. What is A square? A square is 2 times 2, 4, 3 times 1 is 7, mod 5 is 2, right? Then 2 times 3 is 6, 3 times 2 is 6, 12, mod 5 is 2. 1, 2 times 2, 1, that's 4. And 1, 2 times 3, 2. So 1 times 3 is 3, 7, which is 2. Okay? Please check if I'm
Yes, sir.
multiplying the matrices correctly. So 2 times 2 is 4. 3 times 4 is 12. The sum is 16, which is 1 mod 5. 2 times 2 is 4. 3 times 2 is 6, which is the sum is 10. So this is 0. 1 times 2 is 2. 2 times 4 is 10, which is 0 mod 5. 1 times 2 is 2. 2 times 2 is 4. The sum is 6, which is 1 mod 5. So A cube is identity and no smaller powers of A are identity. Therefore, the order is 3. Okay. Now let's move on
Yes,
to
sir.
27. How many generators of Z36 are there? How many
12
generators?
है. 12 है.
Okay. How?
Pi 36.
Yes. So does everybody know how to compute this? Does everybody know how to compute this?
It's phi n when n is the number of uh, Zn. Number of generator in Zn is phi n.
Yes.
So
So how do you compute phi of n? Let's say phi of 36.
phi of 36, which can be
Yeah, go ahead.
phi of 36 is same as phi of 2 square, then phi of 3 square,
Mm-hmm.
which is same as 2 square minus 2 into 3 square minus 3.
Okay. Now how much is this? This is 2 times 6 equals 12. The answer is 12. Is this okay for everybody? P is the Euler phi function, Euler's torsion function, there are many names. And P counts, so P of 36 is the number of elements, number of natural numbers less than or equal to 36, which are co-prime to 36. P of n equals the set of all m in natural numbers such that 1, yeah, let's add that redundant assumption, 1 less than or equal to m, strictly less than n, and the GCD of m and n is 1. Okay, this is the Euler P function. Turns out it's multiplicative, which means if you have co-prime numbers, P of n1 n2 equals P n1 P n2 if n1 and n2 are co-prime. And for a prime P of P power k equals e power k minus 1 smaller power. From these two formulas, you can find out Pn for any natural number n. Okay. Is that fine for everybody?
Yes, sir.
Okay. Now, this 28 is an application of the orbit stabilizer theorem. We can skip this, but if you are interested, you can try this out. This is an interesting problem which leads into higher mathematics. So, there are these spaces called as projective spaces, and you can take P1 of Gp. To count the cardinality of this, you can use orbit stabilizer theorem. But yeah, we can skip this problem. Now, let's look at 29. Let G be a group of order 20 in which conjugacy classes have sizes 1, 4, 5, 5, 5. Then no two Silo subgroup in G is normal. Is this true or false?
नो सर, बिकॉज कॉन्जुगेसी क्लासेस पढ़ी नहीं है तो कोई आइडिया नहीं है इसके बारे में.
Okay, but yeah. Uh, so the idea over here is you can use Philo's theorem. So two Philo, well, let me just tell you the basics of Philo in this problem, and we won't solve this entire problem. You can try this out on your own, but if you are interested, you can contact me later. Uh, so what's the cardinality of a two Philo in G?
और
4, because that's the largest power of 2 dividing the order of G, right?
यस, यस सर.
Now, how many 2 Philos can there be in G? The number of P
आइदर
Philos,
आइदर 5 या आइदर 1.
right? Either 5 or 1. अभी कोई भी Philo में, if you start with any 2 Philo, then its cardinality is the power of 2, and uh, you need to see that all Philos are, sorry, not element, but the group itself, the P Philo has order of power of 2, and if the number of 2 Philos is 1, then it must be normal, then a 2 Philo must be normal,
यस सर.
right? Because all of them are conjugate,
यस सर.
and then you can work this out, but let's skip it. Now can you tell me the order of the subgroup of Gn to Z generated by 0 1 1 0 and 0 minus 1 1 minus 1? So how do you do this? First, try to find the orders of these two elements. A equals 0 1 1 0 and B equals 0 minus 1 1 minus 1.
Order of A is 2 and order of B is 3.
Okay, order of A is 2, order of B is 3. Now last time we saw that one trick to solve these kind of questions is to show that every element in the subgroup can be written as a power of A times the power of B, right?
यस सर. तो
If this happens, then you can just multiply these two numbers, order of A and order of B, to get the order of the subgroup generated by A and B. Okay?
so 6 element.
Yes, but does this happen? I'm sorry for some noises coming from the background. I'm basically besides the Kumbh Mela, so HRI is on the bank of the river Ganga. So there might be some issues, but yeah, excuse me. So what was the trick? The trick was to show that uh, something like this holds. AB A inverse equals the power of B, right? Let me try it one trick. Hello, is this better?
Yes, sir.
Is this better?
Yes, sir.
Yes,
Okay.
sir. Yes, sir.
Yeah. So can you tell me what's the answer over here? Can you compute ABA inverse? So you know that order of A is 2. So A inverse is A, right? What's this? ABA inverse is just 0, 1, 1, 0, 0, minus 1, 1, minus 1, and 0, 1, 1, 0. There are some tricks from which you can directly do this, but let's do this using first principles. So let me quickly tell you the trick. Multiplication by an elementary matrix on the left is doing row operations, and multiplication by an elementary matrix on the right is doing column operations, right? So does everybody know this? So what are
Yes,
we
sir.
doing? If we multiply by A on the left, we are flipping rows. If we are multiplying by B on the right, multiplying by A on the right, we are flipping columns. So this is basically flipping rows and columns, right? So what is the answer? It would be the matrix flipped, but we can directly do the computation.
One.
Right? Now what is B square?
Sir, it is same as the ABA inverse.
Yes. So we have shown that ABA inverse equals B square, right?
Yes,
Yes,
sir.
sir.
So last time we saw that if we have such an equation, then any element which you can create out of A and B can be written in terms of powers of A times powers of B, right? Just a single power of A times a single power of B. Okay?
Yes, sir.
Yeah. So that's the trick. You check if ABA inverse is B power C, or you check the other one, BAB inverse equals some power of A. Okay? Yeah. What about question 31? Let me read it out. Let sigma be 147 times 258 and tau be 14 times 2578. Then the number of etas in S8 such that eta inverse sigma eta is tau is
0.
what's the answer?
zero.
Yeah, why?
Thus, this
Because in asset,
two permutation is
Sorry, what? Too many answers at the same time?
two permutation is conjugate found if they have same cycle decompositions.
Exactly. So sigma and tau cannot be conjugate. Do you know the reason behind that? What is the reason behind that?
because it's cyclic decomposition, not same.
No, yeah, but what's the reason behind the fact that if the cyclic decompositions are not the same, then they cannot be conjugate? So last time we saw something, right? Um, so if I have rho is an element of Sn, then rho and let's say A, B, C, rho inverse. What is this?
It's row A, row B, row C.
Yes, this is rho A, rho B, and rho C. So you can see that if you conjugate a 3 cycle, you get a 3 cycle back. So generalizing this, you can see that conjugation preserves the cycle structure. If it's 3 plus 3, then any conjugate would be a 3 plus 3. Okay. What about question 32? The number of subgroups of order 7 of Z7 cross Z7. How many of them are there?
It's 8.
Yeah. What's the reason?
Mm, the number of element of order 7 divided by 5 7.
What? The number of elements of order 7 divided by 5
Uh,
7.
they are because it has element of order 7, then
Uh-huh. Okay, okay. Let's see. So how do you compute that?
then order 7 element are just 7 square minus 1, because one element is identity,
Yes.
and so वो 48, and देन सब ग्रुप निकालने के लिए 5 7 से डिवाइड कर दिया ऑर्डर को, जितने
ऐसा
एलिमेंट थे
क्यों
उनको,
किया? Why did we do that?
बिकॉज 7 ऑर्डर का एक सब ग्रुप बनाने के लिए एक आइडेंटिटी के साथ वो चाहिए, 6 एलिमेंट तो होने ही चाहिए 7 ऑर्डर के,
Mm-hmm.
so that's why there are element 48, then dividing by 5 7 is
Yeah. So the point is, um, if one element generates a subgroup, then all of its co-prime to 7 multiples generate the same subgroup, right?
yes sir.
If X uh, generates a Z7, then x square, x cube, dot dot dot, x power 6. These generate the same subgroup generated by X. Okay. So 6 of them group together, and that's the reason why this happens. So yeah. So the answer over here is 8. That's correct. And I would like to connect this with problem 28. So somehow the cardinality of P1 ZP is the same as the number of subgroups of order P inside ZP cross ZP. So if you are interested, you can try to connect 32 and 28. Now, how do you answer this question? The maximum order of an element in S10 is
30.
Why?
The LCM of 5, 3, and 2.
5, 3, and 2. And what about other LCMs?
वो इतना नहीं होगा, इसके ज़्यादा 30 से
Hmm.
ज़्यादा नहीं होगा.
How about Q? Why? You can try it out on your own. This is a game. So suppose you have
Cyclic
10.
decomposition.
Yeah. Suppose you have 10, then to find elements of any order, for instance, you can partition 10. So one such partition is 2 plus 3 plus 5, right? 2 plus 3 plus 5 is 10. You take a partition, associated to a partition, you can construct an element. How do you construct the element? You take a 2 cycle, that is 1 comma 2, then take a 3 cycle, 3 comma 4 comma 5, and then take a 5 cycle, 6, 7, 8, 9, and 10. Okay. What is so this is an element in S10, and what is the order of this element?
LCMs of these three.
Yes, LCM of orders of these. Why? Because they all commute. Disjoint cycles commute, therefore
Yes,
the
sir.
order of the product is the LCM of their orders. Order of this element is
2,
2. What about this?
3, and
3 and
this is 5.
5. So you have to take the LCM of 2, 3, 5, and that is 30 because they are all primes, they are co-prime with each other. So the LCM is the product. And so this is just a game. You can take any number over here, try to write down as many partitions as possible, and take the LCM of numbers appearing in the partition. So can somebody tell me a different partition of 10?
7, 3.
Yeah. So if I write 7 plus 3, then this partition corresponds to an element. I mean, this partition gives you an element of order.
21.
Yes, 21, because that's the LCM of 7 and 3. They are co-prime, so the LCM is the product. This is just a game. You can try to play this. Now, what about question 34? Find a chain of subgroups 0, H0, H1, dot, 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 Hn in S4 such that Hi minus 1 is normal in Hi. So a step in this thing, across a step, the subgroup is normal in the bigger group. So maybe we can start from the right. S4. What's a subgroup of S4? What's a normal subgroup of S4?
Identity
Yeah, but let's do something better.
K4, A4.
Yeah. So you can start with A4 on the right. Then one more normal subgroup inside A4. That's the client 4 and identity. Okay.
Yes, sir.
What's the client 4 inside S4? What are the elements in that?
Uh, Identity and then two order के element. मतलब दो two order के element and one is their product.
Yeah. So yeah, but what? I want explicit elements inside S4 which generate K4.
One, two, three, four. Cycle 1, 2, cycle 3, 4.
Yes. 1, 2, 3, 4 and 1, 2
One.
times 3, 4. Okay. Next, yeah, can you find the quotients? It's an interesting thing, but you can try it out on your own. Now, let G be a finite abelian group such that Hom from G to Z221 is 0. What can you say about the order of G? Mhm.
Sir, order of G is not divisible by 221?
The order of G is co-prime to 221
Yeah.
because any divisor of 221 will also have homomorphism. That's it. If every cyclic subgroup of a group G is finite, is G finite? What's the answer?
No.
Why?
Q cosine Z, I guess. I
Yes.
cannot remember.
Yeah, you don't have to remember. You can check. Mathematics is not just a science of remembering. You can check things. So Q mod Z. Uh, so what about this group? Start with a cyclic subgroup of Q mod Z. So cyclic subgroup means it has a generator, right? So suppose I pick an element, let's say P by Q. This is in here. Now, does P by Q generate a cyclic subgroup of finite order? What's the answer?
Yes.
Yeah. So why?
After adding it for Q times, we will get one. We will get an integer value.
Yes. So P by Q, if you add it to itself, this is an additive group, Q times, you will get P, which is 0 in Q mod Z. Therefore, the order of P by Q is finite. We don't know if it's Q. If P and Q are co-prime, then you can be sure that the order is Q. But at least this is the order of P by Q is finite. Now, order of an element is finite is equivalent to saying the order of the subgroup generated by that element is finite, right?
Yeah, got it.
If X is an element in G, then order of the subgroup generated by X is the same as order of X, right? Now, order of P by Q is finite, which means the order of the subgroup generated by P by Q is finite. This means every cyclic subgroup every cyclic subgroup of Q mod Z is finite. But is the group finite?
No.
No. Yeah, that's the point. Yeah. For every n in n, let mu n be the subgroup of nth roots of unity in C star. Is union n going from 1 to 2025 yn a subgroup of C star? What's the answer?
Sir, what is yn?
Oh, sorry. There's a typo. This should be mu n. This should be mu n, sorry.
No, sir.
Why?
Uh, because the union of subgroups may not form groups, a subgroup.
Yeah, but that's a may not statement, right? Is it a subgroup or not?
No, sir.
Okay, why?
रीजन नहीं पता सर.
अरे तो बोलो।
So you can check by taking values for n.
Okay,
if we
but
अगर
at
कोई
least
भी
tell me
दो
one
सबग्रुप
reason.
समझता है
What? Yeah, yeah.
अगर कोई दो सब ग्रुप्स लेते हैं और उसका यूनियन इफ एंड ओनली सब ग्रुप होगा अगर एक दूसरे का सबसेट होगा या दूसरा पहले का.
Yes. So that's one of the reasons, and you can check key that may not happen over here, right? But one direct method of doing this is to combine roots of unity to create a different root of unity, but of very large order. So suppose you choose two primes less than 2025, P and Q, two primes less than 2025, such that their product is bigger than 2025, then you'll get a counter example. You'll get a problem in the group, right? The product of two elements won't be in the group. Is that okay? Yeah.
सर
Mhm.
यहाँ पे फाइनाइट की जगह अगर इनफाइनाइट यूनियन हो तब भी सब ग्रुप नहीं बनेगा वो.
नहीं बनेगा. Why?
नहीं पूछ रहा हूँ मैं बनेगा कि नहीं बनेगा.
Yes, it will be. It will be a subgroup. The point
सर,
is product
इ-
of any two what? क्या?
कैसे मतलब एक बार बता
Yeah.
दीजिए आप.
The point is product of any two roots of unity is again a root of unity, right?
यस सर.
That's it. So if you start with okay, so is union n equals 1 to infinity mu n a subgroup of G, I mean C star. Answer yes. Reason what do we have to check? We just have to check the closure property, right? Non-emptiness is fine because 1 is a root of unity. And if x comma y they are in the union mu n, then x to the n1 equals 1 and y to the n2 equals 1 for some n1 comma n2, right? What does this mean? The product, if you raise the product to the power n1 n2, you get 1. The reason is this is a subset of C star, so x and y would commute, and therefore x y to the power n1 n2, this will equal x power n1 n2 y power n1 n2, which equals 1 times 1, which equals 1. Is that fine?
Yes, sir.
Yeah. So this is an interesting subgroup of C star, and in fact, I mean, yeah. So in number theory, this is really interesting. All roots of unity. Okay. Now you can try this out. Find the order of this in S6. So can you tell me how to approach this problem? Slightly easier than some of these.
सर पहले तो इनका प्रोडक्ट करेंगे क्योंकि ये डिसजॉइंट नहीं है
Yes.
एंड देन वी फाइंड द ऑर्डर.
Yes. Then just the LCM of a cycle I mean, orders in the cycle decomposition.
यस सर.
Is that fine with everybody?
Yes, sir.
Yeah. Now the number of elements in A6 of order 6.
Is 0.
0.
Why?
Because A6
So
is a even permutation and a cycle of 6 or order 6 is not even. मतलब इसका जो ट्रांसपोजिशन बनेंगे वो इवन नहीं बनेंगे, ओड बनेंगे, तो वो A6 में कंटेन नहीं होगा.
You? Why? Why can't that be even? I
the
mean, yeah.
only element of order 6 in
Mm.
S6 is a cycle of 6 and which is odd, which is
Mhm.
not even. So there is no element of order 6 in A6.
Are you sure about the first statement?
Um,
In
no, sir.
S6, okay.
No,
In
there are
S6,
various, but the partition will be one. That is 6. The
is that true?
element of um.
How about 1, 2, 3?
Oh, sorry, I forgot that.
Yeah, but that's also odd because of 2 in it. So, yeah, the answer is correct. The reason was slightly wrong, but yeah, you get it. You can try this out. HKB subgroups of Z144. If order of H is 24 and order of K is 36, then H intersection K has order. So let me,
12.
yeah. Why?
Because H intersection K is subgroup of H and K also.
Okay.
Then in order of H intersection K must divide order of H and must divide order of K by the Lagrange theorem.
Mm-hmm.
Then its order must divide the GCD of order of H and order of K, and
Mm-hmm.
GCD of 24 and 36 is 12. Then its order must be 12.
It should only divide 12, right? Why does it need to be 12? Why does it need to be 12? It just the order of H intersection K just divides the GCD.
बट सर फिर इससे अगर मतलब कम हो जाएगा या ज्यादा हो जाए, कम हो जाएगा तो ये जो एच के सब ग्रुप बन रहा है वो नहीं बनेगा ना, इसका ऑर्डर 144 से ज्यादा हो जाएगा.
Why? What are you using?
एच के जो सब ग्रुप ऑफ
Yeah. So there's this theorem that order of HK is order of H times order of K divided by order of H intersection K. Right?
Yes, sir.
This is correct. How do we get this? From one of the isomorphism theorems we can get this, right? What do we know? We know that HK mod K is isomorphic to what's the isomorphism theorem here? You cannot forget these.
K by H intersection K.
Yeah. K by H intersection K?
K mod H intersection K.
Is this correct?
HK by K. No, sir. It's H.
Yes. It's H mod H intersection K. Now, you can therefore say that order of HK mod K is the same as order of H mod H intersection K. Now, what is the order of this quotient? That's order of HK divided by order of K. The same over here. And then just algebra. Order of HK equals order of H times order of K divided by order of H intersection K. Now what? What's the answer? You said something like if H intersection K, the order properly divides 12, then HK would be bigger than the group. वो कैसे आएगा? Is that true? How do you see that? There's a direct measure to do this if you forget formulas. So, I mean, forget the final answer. So, in Z144, this is the group G. If H is a subgroup of G such that order of H is, let's say, 24, then can you say H is generated by something? Can you tell me what is H generated by? You want an element whose order is 24, right? So how do you get an element of order 24? You divide 144 by 24.
6.
Yes. So if you look at the subgroup generated by 6, then that's an element of, I mean, that's a subgroup of order 24. Now, um, can you tell me what K is generated by? Order of K is 36.
Or
Yes. So that's generated by 4. Now, H intersection K consists of all elements which are in H and which are in K, right? So all those elements which are divisible by 6 and divisible by 4. So the trick over here is to note that all elements over here will be generated, sorry, all elements in H intersection will be, H intersection K will be divisible by 12. So 12 generates H intersection K. Now, what's the order of 12 inside Z144?
12.
Yes. It's because you divide 144 by 12 and the answer is 12. That's how you arrive at the answer. But yeah, you can get some direct form. You can derive some formula like this. Okay. Is there an injective homomorphism from K4 to Z8? What's the answer?
No,
No, sir.
Why?
because K4 is not a subgroup of Z8.
Yeah, why not?
Because K4 has a three element of order 2 and Z8 has only one element of order 2.
Yeah, that's the reason that K4 has too many elements of order 2. If there is an injective homomorphism from a group to the other group, then you can think of the first group, the domain group, as a subgroup of the codomain group. Is that fine?
Yes, sir.
So if F from G to G prime is injective, then G is isomorphic to a subgroup of G prime. Okay? Then G is isomorphic to a subgroup of G prime. But as you said, here G is K4 and G prime is Z8. If G is isomorphic to G, a subgroup of G prime, which means K4 is isomorphic to a subgroup of Z8, but K4 has three elements of order 2 and Z8 only has a single element of order 2. Okay? Now, is there a surjective homomorphism from Z8 onto K4? What's the answer?
Again, no.
Why?
Sir, by the fundamental theorem of homomorphism,
Mhm.
G की homomorphism का G by kernel of homomorphism so equal is isomorphic to f of G,
Yes.
and if G is abelian या cyclic then it's जो homomorphism जो subgroup बनेगा वो भी cyclic ही बनेगा, तो वो जो G by kernel G बनेगा वो Z4 के isomorphic बनेगा, तो that's why then there is no onto
Yes.
homomorphism.
That's the reason. So if if F from G to G prime is surjective, then G prime is isomorphic to G mod kernel F, right? Which isomorphism theorem is this?
First one.
Just yes, just so that we can compare lectures. This is the first isomorphism theorem. And here G is taken to be Z8, Z mod 8Z, and G prime is taken to be K4. Now, G is cyclic, so all of the quotients of G are cyclic. G is cyclic implies G mod kernel F is cyclic. And this isomorphism will then imply G prime is cyclic. But is K4 cyclic?
No, sir.
No, because all elements, all non-identity elements are of order 2. So they cannot generate anything bigger than a group of subgroup of order 2. Now, let's go to question 42. Let G be a group and fix an X in G. Is the map F from G to G defined by Fy equals Y X Y inverse a group homomorphism? What's the answer? You can try to think about this, but the point is this is a group homomorphism,
Yes, sir.
but only if, I mean, if this G is replaced by aught G. If you take this map from G to automorphisms of G, then this is a group homomorphism. Okay. Is that okay?
सर एक बार फिर से एक्सप्लेन करना.
Yeah. You can think about this precise question later, but my point over here is that F is a homomorphism from G to aught G. If you replace this second G by aught G, then this is a homomorphism. Okay. So this is just a trick kind of a question. One might look at this and say
इसका
yes or no, but
इसका तो नहीं होगा ना सर ये होमोमॉर्फिज्म.
हाँ, ये क्यों नहीं होगा? You need to produce a counter example. That's the point. But yeah, you can think about this later.
सर बिकॉज जी अबेलियन भी नहीं दिया गया है तो
Mm-hmm.
तो ओके. जब जब प्रोडक्ट वाला करेंगे इसमें मतलब एक y का ले लिया देन f ऑफ z इक्वल टू z x z इनवर्स एंड देन उनका प्रोडक्ट करेंगे f ऑफ y z देन y z x y z इनवर्स. अब y इनवर्स z इनवर्स देन वो कैसे बनेगा मतलब वो.
So, but when you have to produce a counter example, you're saying that this is not a group homomorphism in general. So you have to produce a counter example, na?
ओके सर.
Yeah. So the point is, let me tell you the answer maybe. So if you take G to be abelian, then for any y, the image is X, right? For any y, the image is X. Uh, but that cannot happen, right? If X is not identity, that's the trick. You can think about it later. But yeah. This is called conjugation. And yeah. Okay. Let's skip question 43. That is just again computing orders. What about question 44? How do you solve question number 44?
इसमें सर मतलब वही एलिमेंट लेने ना जिनका स्क्वायर करने पर डिवाइड करे 55 से देन रिमाइंडर शुड बी इक्वल टू 26.
Yes, yes. Do we check all elements which are co-prime to 55, compute their squares, take the remainder and check if it's 26? Is that the strategy? What's the strategy? Yeah. So let me tell you the strategy. Over here, the group which we are interested in is Z55 star, right? The units inside Z55, Z mod 55Z. So we know that this is isomorphic to a product of, I mean, a direct sum of two groups. How do you compute that? Write 55 as 5 times 11. Write down the prime factorization of 55. So Z55 star is a direct sum of Z5 star and Z11 star. Is this okay for everybody?
Yes, sir.
Yeah. To see a proof, maybe you need to go to ring theory. And the idea is Chinese remainder theorem. In fact, these two rings are isomorphic if you forget the stars. And then once two rings are isomorphic, their units are isomorphic. Okay, but fine. You can just remember this, that Z55 star is isomorphic to Z5 star, Z11 star, because 55 splits into two things, 5 times 11. Okay. Now, inside ZP star, if P is a prime, then in ZP star, the cardinality of this set x square equals n. This is 0 or 2. Okay. This for a fixed n. What does this mean? So in ZP star, you can fix an n. For instance, in Z5 star, you can fix 4. Then how many x are there such that x square equals 4 in Z5 star? They are 2. Let's do this small exercise. For Z5 star, n and the cardinality of x in Z5 star such that x square equals n. So you can start with 1. How many elements are there? How many x are there such that x square is 1 in Z5 star?
One.
And
Did
4.
you check all of them?
And 4.
Yes, 1 and 4. So the cardinality is 2. What if n is 2? How many x are there whose square is 2 in Z5 star?
There are no elements.
So this is 0. What about 3?
Same, there is no.
Yeah, this is also 0. What about 4?
It's 2.
Yes, the answer is 2. So you can see that this number is either 0 or 2, right?
Hmm.
So we have checked this statement when p is 5. Okay. So you can remember this, that in ZP star, the number of all x such that x square is a fixed number n is either 0 or 2. Okay. Now, to uh, to prove this, you'll need to either note that ZP is a field. I mean, Z mod PZ is a field, or you can look at quadratic reciprocity. But yeah, there are many ways to prove this, but you can just remember this. Now, if you pick an element over here, let's do this on a new page. Z55 star is isomorphic to Z5 star direct sum Z11 star. Okay. Now let me tell you how this map works. So if you start with an element, let's say 26 bar over here, then this map sends that element to 26 bar comma 26 bar. It's this easy. Okay. Is this okay for the time being till this point?
Yes, sir.
Yeah. This is the diagonal map sending 26 bar to 26 bar comma 26 bar. Can you tell me what this equals in some nice language over here? What is 26 bar equal to in Z5 star?
1, 4,
1,
Yes, that's 1. And what about 26 bar in Z11 star?
4.
4.
Yes, that's 4 bar. Now, you want an element in, you want to count number of elements in Z55 star such that their square is 26, right? So
Yes, sir.
x such that x square is 26 bar. This means x bar comma x bar square equals 1 bar comma 4 bar, right? Is this
Yes.
fine? Because under isomorphisms, you can transfer these things.
Yes, sir.
This is an if and only if statement. Now, can you count the number of x's such that this happens?
It is either 1 or 4.
It is either
1 or 4.
why 1?
Since it's 1 bar, um, I can't explain.
Okay, okay. No, you can use whatever we said over here, right? If you fix an n, then the number of x such that x square is n is either 0 or 2, right?
Yes.
So now uh, there is a point you can um, you can directly count the number of a bar and b bar whose square is 1 bar and 4 bar. Can you do this? Suppose this is not restricted. I mean, it's not restricted that a equals b. We don't have that assumption. Now, can you do this? So what does this mean? This means you take a bar square comma b bar square, right? So if these three are equal, means these two are equal, then you want to find all A in Z5 star. This A bar has to be in Z5 star and B bar has to be in Z11 star. Okay. You want to find A bar in Z5 star, B bar in Z11 star such that A bar square is 1 and B bar square is 4. Now forget B bar for the time being. Can you do this for A bar? Can you count the number of A bars such that this happens?
Two.
Yes, we know that it's either 0 or 2, but it's not 0 because 1 square is 1. Therefore, the answer is 2. Okay. What about B bar? Again, the number of B bar such that B bar square is 4 is either is either 0 or 2, right? Hello? Okay. Am I audible?
Yes, sir.
Okay, okay. From this last result, we know that the number of B bar, 11 is prime, right? 11 is prime. B bar, the number of B bars such that B bar square is 4 is either 0 or 2. Is that okay?
Yes, sir. Yes, sir.
Yeah, it's either
It's
0 or
true,
2.
sir.
But can it be 0? Yeah, someone said the answer. Why is it 2?
Because 2 square and also 9 square.
Yeah, 2 square and 9 square. But you could have just said that 2 square is 4. The answer is not 0, therefore it's 2. Okay. But yeah, it's nice that you went ahead and computed the square roots. Um, okay. So there are two A bars such that A bar square is 1. There are two B bars such that B bar square is 4. Then how many A bars comma B bars are there? How many ordered pairs are there whose square is 1, 4?
The number of combinations 4.
4.
Yes, the number of combinations, which is 4. 2 times 2 is 4. That's the strategy to solve this. Okay. And you can go one step beyond. You can show that the number of x such that x square equals 26 or x square equals any number in Z55 star, it's either 0 or 4. The number of elements x in Z55 star such that x square equals n is 0 or 4. You have to first fix an n inside Z55 star. It's just this argument repeated. Okay. So you can remember this result. It's either 0 or 4. And to say that the answer is 4, you can show that the answer is not 0, which means you just have to find one x for which this happens, right? For which x square is 26. Now you can try out some combinations. So one interesting thing is 26 bar is also 81 bar over in this group, right? 26 bar equals 81 bar in Z55 star, right? Which equals 9 bar square. So the answer is not 0, therefore the answer is 4. Is this okay?
Okay, sir. Okay.
Yeah. 45. the cardinality of this set is what's the answer?
4.
Yeah, how?
uh, because we know that it's something x raised to the power n equals identity, then order of x must divide n, and here n is 4, then order of x must divide 4.
Yeah,
So so order of x is either 1, 2, or 4.
right,
But in S3 there is no element of order 4, so order of x is 1 and 2, and the element is 4, because 2 order का element 3 and 1 order is identity.
right. So x power 4 equals identity implies that order of x divides 4, which means order of x is 1, 2, or 4. Now, in S3, the number of elements of order 4 are 0, the number of elements of order 2 are 3, and the number of elements of order 1 is 1. There are 3 elements of order 2, 1 element of order 1, no elements of order 4. Just add these and you get 4. Is that okay? Yeah. Now, what about question 47? So you have to look at all theta in R such that order of e to the power 2 pi I theta is infinity in S1. Everybody knows what S1 is? Does everybody know what S1 is?
Yes, sir.
Unit circle in complex plane.
Yeah, S1 is a unit circle in the complex plane and it's a multiplicative group. Okay? It contains all roots of unity, for instance.
Yes, sir.
Now, you have to look at all thetas such that order of e power 2 pi I theta is infinity. So what can you say? So can you tell me uh, what are the thetas for which e to the 2 pi I theta is 1? Let's call it uh, x maybe. E to the 2 pi I x equals 1 if and only if x is in R and e to the 2 pi I x is 1, then this is equivalent to yeah. So the answer is e to the 2 pi x is 1 if and only if x is an integer. What's the reason? E to the 2 pi I x is cos 2 pi x plus I sine 2 pi x. Okay. Now this is 1 when cos 2 pi x is 1 and sine 2 pi x is 0. Now when is sine 0?
Integer.
N pi.
Yeah, sine is 0 on n pi, and if sine is 0 then cos can have two values, right? it can be plus or minus 1.
Minus.
On n pi, cos takes two values. On all odd multiples of pi, cos takes
-1.
-1. And on even multiples of pi, cos takes
1.
1. So do you get how this equivalence is true now?
Yes, sir.
Yeah. So e to the 2 pi I x is 1 if and only if x is an integer, right? So now, using this fact, can you tell me what's the answer to 47?
Z is not dense, right?
Yeah, Z is not dense, but are you saying that this set is Z? So tell me what that set is. Maybe that's slightly easier. So suppose order of e to the 2 pi I theta is finite. Let's say it's n. What does this mean? What does this mean? What's the definition of order? This means e to the 2 pi I theta raised to the power n, which means, okay, this raised to the power n equals 1. This means e to the 2 pi I theta times n equals 1. This means theta times n is an integer, right? So this from this series of equalities, we can see that if the order of e to the 2 pi I is finite, I mean order of e to the 2 pi I theta is finite, then theta is a rational number. Is that okay? I'm saying at the end theta times n in z, this implies theta is in q. Okay, and it's an equality. Yeah, I mean
Yes, sir.
equivalence. Yeah,
Yes, sir. Yes.
so theta is in q, which means if order of e to the 2 I pi theta is finite, then theta is rational and it's equivalent. You can check. Therefore, this set consists of,
Irrationals.
yeah, this set consists of irrational numbers. Are those dense?
Yes, sir.
Are those countable?
No, sir.
Okay, that's it. Now, what about this? Let
But
mu.
sir,
Mhm.
अगर यहाँ पे फाइनाइट होता देन क्यों आता, है ना?
हाँ,
एंड वो
yes,
तो डेंस एंड काउंटेबल दोनों.
yes.
ओके सर.
Okay. Let mu 2025 be all 2025 roots of unity, and let G be this group and H be this group. Then can you count the index of H in G? Yeah. Over here, the idea is um, coset representatives of H in G are given by diagonal matrices zeta 0, 0, 1. Okay. One can try to prove this, that coset representatives of H in G are given by zeta 0, 0, 1. Okay. And then it's just a question of how many 2025 roots of unity are there. So there's that.
2025.
Yeah, that's the answer. So since I'm nearing the end of the lecture, maybe I can skip some problems.
सर ये शेयर भी कर देना ये प्रॉब्लम शीट हमको.
हाँ, yes, yes. So let me see. Yeah, let me skip these two problems. Okay, what about question 51? Let's use some numericals. The number of elements in Z50 of order 10. What's the number?
4.
4. Why?
5, 10.
Yeah. In a cyclic group, you can always count the number of elements of a certain order by phi of that number. So in Z mod nz, the number of elements x in Zn such that order of x equals d is phi d. And everybody knows how to evaluate phi of d for any number d. We saw that few pages ago. Now let's do this. Characterize the subgroups of Q of finite index. So can you tell me, so let's do an easier question.
Sir,
What are subgroups? What are the finite subgroups of Q? Can you characterize finite subgroups of Q?
yes sir.
Yeah, what are those?
Uh,
Is there a subgroup of finite is there a subgroup of finite order in Q? So identity is one. What about cyclic subgroups generated by other elements? Are those finite?
yes sir.
Okay. What's the reason?
सर एक बार क्वेश्चन रिपीट करना वापस.
Uh, Non-trivial cyclic subgroup of Q, is that finite? Cannot be,
नो
right?
सर. नो सर. हाँ.
Yeah, why?
बिकॉज
What's the order of P by Q?
क्यू.
Is it true? What's the order of P by Q inside rationals?
Infinite.
Yes. The order is Q inside Q mod Z, but not in Q. So in rational numbers, you don't get finite order elements, right? So cyclic subgroups of Q are either trivial or those are isomorphic to Z. The infinite cyclic subgroups. Now you can try to figure this out. That is there a subgroup of finite index in Q? And some you can try to do it for C star.
ओके सर मैं क्यू बाई जेड सोच रहा था.
Okay, okay. So now let's go to question 54. Is Q mod Z isomorphic to Q? No, right? Because right
नो
now
सर.
we said, yeah, every element over here has finite order, and over here there is only a single element of finite order.
फाइनाइट ऑर्डर.
Yeah. Now, what about Q mod Z and C star?
नो.
Yeah, why?
बिकॉज क्यू बाई जेड के पास इनफाइनाइट ऑर्डर का कोई एलिमेंट नहीं है. मतलब
Right.
इसके पास ओनली फाइनाइट ऑर्डर के एलिमेंट एंड सी स्टार के पास इनफाइनाइट ऑर्डर के भी हैं.
Yes. So there are infinite order elements in C star, but every element in Q mod Z is of finite order. Now, how about Q mod Z isomorphic to S1? Again, the same, right?
यस सर.
Every element in Q mod Z is isomorphic to, has finite order, but there are elements in S1 which have infinite order. Now, for these last two questions, there's a trick. If you have an isomorphism between two groups, then their cardinalities have to be the same, right? But Q mod Z is countable and C star is uncountable. Similarly, Q mod Z is countable, S1 is uncountable. And yeah, so Q mod Z is not isomorphic to S1. However, Q mod Z is a subgroup of S1, and that subgroup is precisely union of all roots of unity. Is that okay?
So what is
सर
S1?
दोबारा से रिपीट करो एक बार.
Yeah, S1 is the unit circle inside the complex plane. S1 is
Yes,
the
sir.
unit
Yes, sir.
circle inside the complex plane, and Q mod Z is not isomorphic to S1, but Q mod Z is isomorphic to a subgroup of S1, and that subgroup is all roots of unity. And how do you realize this? Using this map, e to the 2 pi I theta map. So if you start with an element theta inside Q mod Z, you can send it to e to the 2 pi I theta. That would be a root of unity, and you'd get a bijection. And it's a group isomorphism between Q mod Z and a subgroup of S1. And that subgroup is precisely this thing, which we saw at the beginning of the lecture. Uh, where is it?
Sorry to interrupt you, sir, but there is a
Yeah.
physics lecture lined up after this.
Okay. I think my time's up. I was trying to point at this. Here we mentioned the fact that union n equals 1 to infinity mu n is a subgroup. And yeah, so that subgroup is precisely the image of Q mod Z inside S1 under this map. Okay, so any doubts till this point?
No, sir.
Okay,
No, sir.
yeah. Thanks for attending. I think that's it for the lecture.
We are deeply grateful for your presence and insightful talk, sir. We appreciate the time you took to share your valuable knowledge with us. Thank you for your valuable contribution to this workshop. We are honored to have you with us. Thank you so much, sir.
Thank you.
The feedback links have been shared in this chat box. So participants are requested to fill that feedback form.
Thank you, sir.
सर
Yeah.
सर वो ये प्रॉब्लम शीट आप शेयर कर देते कमेंट सेक्शन में तो
Yes. Maybe I'll send an email. Send this via email.
ओके सर
Maybe I'll look at some of the typos. I'll correct those and I'll send it to you.
ओके सर थैंक यू सर
Okay, see you.